Good evening, students. Today we are going to discuss an important question from relations and functions. Before solving the question, let us recall the three important properties of a relation. Okay, one is reflexive, one is symmetric, one more is transitive. Okay, before discussing this question, first understand what is the meaning of reflexive and symmetric and what is transitive. If you understand these three properties, you can able to understand questions. You can able to solve given questions. First, we understand reflexive. Let us consider relation in A. Okay, relation in A. Okay, that is meaning. What is the meaning of this? We represent relation with capital R. A is any set, maybe natural number, real numbers, any set. Okay, any set. Okay, this is meaning that the relation R is mapping from A to A. Okay, you clearly understand what is the meaning of R in A. Okay, sometimes some books may be used on 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 R on A. Some books maybe they use R in A. Okay, the meaning is R is mapping from A to A. Is this clear? Okay. See, to understand better way, I will consider a set A like this 1, 6, 9, 10. Just I consider a one set A. Let us discuss a relation R. Okay, let us discuss a just I will forming one relation like this. Okay, just I am forming a relation like this. I consider a relation. Now I am going to discuss what is reflexive, symmetric, transitive. First one is reflexive. First, let understand what is reflexive. Reflexive nothing but every element of A should be related to itself. Every element of A, okay, related to itself. Okay, mathematically, let some element A belongs to A. Okay, that implies if A is related to itself A only, therefore we say that R is reflexive. Okay, see, we can write this as like this also. A comma A belongs to R. You can represent like this or like this. The both are same. Okay, representation is same. The meaning is same. Representation you can represent like this or like this. The meaning is same only. Okay, what is the meaning of? See, I consider this set. This set. What are the elements it contains? 1, 6, 9, 10. Correct? See, if I want to say this is reflexive, 1 should be related to 1. That is nothing but 1 comma 1. This element should be present in relation. And 6 is related to 6. That is nothing but 6 comma 6. This element should be present in relation. 9 is related to 9. That is nothing but 9 comma 9 should be related to belongs to relation R. Finally 10 is related to 10. That means this element 10 comma 10. Okay, this element also should be present in relation. We have to check whether 1 comma 1 is present in given relation. No. If it is not present, okay, even single pair is not present, we call this is not reflexive. Okay, this is not reflexive. Okay, 1 comma 1 is not present in the given relation. That means it is not a reflexive. If all these pairs present in given relation, then we say that it is reflexive. Otherwise, it is not a reflexive. I hope it is clear. Next, let's understand symmetric. Symmetric. Let consider A comma B. These two elements present in set A. Okay, and A comma B. This pair. Okay, this A comma B present in relation R. Okay, if you take ulta, just interchange the positions. Just interchange the positions. B in place of A take B, in place of B take A. Just interchange the positions. Okay, this pair also should be present in relation. If it is present is if it is like this, then relation R, that implies relation R is symmetric. Okay, let's given what is the relation is given. This is the relation. I am going to check what is the first element 1 comma 6. This is belongs in given relation R. Now I am going to check that implies whether 6 comma, if I will interchange the positions, 6 comma 1 belongs to the relation or not. 6 comma 1, 6 comma, yes, it is there, 6 comma 1. Okay, then next element 6 comma 1 is belongs to the relation. If I will interchange the positions, 1 comma 6 is also belongs to the relation, and 6 comma 9, 6 comma 9 is belongs to the relation. If interchange the positions, I will get 9 comma 6, but 9 comma 6, this pair, this element does not belongs to the relation. Okay, 9 comma 6 is there? No, it is not there. Then therefore R is not a symmetric. Then R is not a symmetric. I hope you understand what is the meaning of symmetric. Let's come to final one, transitive. Let's understand last definition, last type. Okay, what is last type? Third one, transitive. Let consider let consider three elements. There are these three elements belongs to A. Okay. Okay. First, let you need to consider two pairs. First pair like this A comma B. This should be belongs to R, and you have to observe that the last here this last element is B. Again, you need to consider a pair which is starting with B. Okay, we have to find a pair, okay, which is starting with B. What is that pair? B comma, for example, B comma C. This is also belongs to the relation. Okay, then definitely the first and last, if you form a pair, okay, this is also must be belongs to the relation. Then that implies if it satisfies this condition, then R is transitive. Otherwise, the given relation is not transitive. Come to this example. Okay, this is the relation. I will copy this. Okay. Okay. First, we have to consider the pair 1 comma 6. We have to identify is there any, this belongs to relation, correct? We have to identify is there any pair which is starting with 6. Yes, this is the pair, and 6 comma 1 is belongs to relation. Now we have to check the first year and this last form a form pair 1 comma 1. We have to check whether 1 comma 1 is belongs to the relation. No, it is does not belongs to the relation, then it is not transitive. If it is belongs to this relation, this is transitive. Okay, and we identify, see, there is a this is a pair 6 comma 9 belongs to relation. Is there any pair which is starting with 9? No, there is no other pair. That means this pair automatically a transitive. Okay, no need to check this one for this. This also 10 comma 6. Is there any pair? Yes. Here ending with 6. And there is a pair which starting with 6. Okay, right? Then we have to take 10 1. They form a pair. Okay, this is also does not belongs to the relation. If it is belongs to the relation, it is satisfied our condition, but it is not belongs to the given relation, then it is not a transitive. Even one element, okay, does not contain, okay, then we call it as not a transitive. And one more thing, equivalence relation. Fourth one, equivalence relation. What is the meaning of equivalence relation? Equivalence relation is that nothing but if the relation is reflexive, symmetric plus transitive. If the relation is reflexive, symmetric, transitive, if the both these three properties are satisfied, then such type of relations we call as equivalence relation. Okay. Then after that, come to this question. In this question, let n be the set of natural numbers. That means our a is given. A is nothing but here natural numbers. Okay, natural numbers are given, and relation b in n. See, it is clearly it is mentioned that uh, R be in relation in n. This is nothing but R is mapping number to natural number. Okay, and the relation is given. What is the relation is given? A comma b such that a is a factor of b. Okay, this form we call a set builder form. Okay, this form we call a set builder form. If it is relation is given in this form, okay, this form we call as roster form. Okay, okay, see here, what is this? A is a factor of b. What is the meaning of this? Let's discuss what is the meaning of this. Just let decode what is the meaning of a is factor of b. Okay, for example, if I will tell 4 is factor of 12, what is the meaning of? The meaning is, if I'm saying 4 is a factor of 12, that meaning 12 should be divided 4 completely. Okay, 12 divide, sorry, 4 divides 12 completely. Completely means if after dividing 12, okay, 4 3 is a 12, you get remainder 0. Should get remainder 0. That is the meaning of 4 is factor of 12. That means I can write like this in this format, 12 by 4. 12 by 4. After dividing, I will get some natural number. What is that? 3. I will rewrite this as 12. I can rewrite as 4 into some 3. Okay, in general, 12 into 4 into, instead of writing 3, I will write as some k. K belongs to any natural number. Okay, k belongs to any natural. Can I write like this? Okay, similarly for general, b, 12 here what? B. B is equal to A is what? 4. 4, sorry, 4 is in place of 4, A. A into K. K belongs to some natural number. Okay, that means A is a factor of B, nothing but B is equal to A into K. I can express like this. That means B divides So b divisible by a. Okay, that means if you divide b with a, it divides completely, leaves remainder 0. This is the meaning. Okay, let's come to this question. This is my relation. We have to show it is reflexive. Okay, how to show it is reflexive? How to show it is reflexive? Let consider a number which is belongs to relation. Sorry, not relation. Set A. That means our set is natural number. Okay. Let A belongs to any natural number. A is any natural number. No matter. It is any natural number. Now A is a factor of B. Okay. This is the relation is given. Okay. If I will write A is related to A. Okay. A comma B. In place of B also I am taking A only. Okay. A is related to A. That means for every element in natural number is related to itself. Okay. That means A is a factor of itself. Okay, A is a factor of itself. That implies our relation R is reflexive. Okay, if you want example, you can write like this. See, itself means that is nothing but A. Okay, divides A. We can write like this. Otherwise, if you want, write like this also. A divides A. A get cancelled. What we get? 1. A and A get cancelled. We get 1. For example, you consider any natural number. For example, 2 belongs to a natural number. Okay. If 2 is a factor of itself, that means 2 divides 2. It both 2 get cancels. It completely divides, leaves remainder 0. Yes. Okay, 2 get cancelled, we get 1. Okay. The number itself in natural number, any natural number itself a factor. If you consider a 12, okay, definitely there are 2 factors. Okay, 1 and itself. 1 and itself. Okay, 1 and itself is always a factor for any natural number. Okay, first condition is satisfied. Then second one, what is symmetric? Symmetric. Say we have to show it is not symmetric. Okay, to show it is not symmetric, just consider any example. Okay, I will consider there are 2 numbers, 2 and 4. Okay, these 2 numbers are belongs to natural number only. Okay, we know that 2, okay, 2 is related to 4. We'll write 2 is related to 4. That is meaning that 2 is a factor of 4. 2 is a factor of 4. But 2 is a factor of 4. Yes. 2 divides 4. Okay, leaves 2 divides 4 completely, leaves remainder 0. This is true. But 4 is not a factor of 2 because 2 by 4 they both are, say, 4 does not divides completely. It is a smaller number, it is a big number, it does not divides completely. Okay, it not gives remainder 0. Yes or no? We cannot express 2 as, okay, 4 into some natural number k. We cannot express, tell me any natural number. If you multiply with that natural number, we get 2. Suppose even if I will take natural number k is equal to 1. 1 is a natural number. If I will substitute here 4 into 1, 4. 2 does not equal to 4. Okay, this condition is not satisfied. This condition is not fulfilled. Okay, that means 4 is not a factor of 2. That implies 4 comma 4 is does not related to. I will use the symbol like this. Otherwise, you can write like this also. 4 comma 2 does not belongs to relation. Yeah, this is nothing but 2 comma 4 belongs to relation. But if you interchange the positions, okay, this is does not belongs to the relation. That implies relation R is not a symmetric. It is not a symmetric. Next, third condition is what? Transitive. We have to show it is transitive. Third condition, transitive. Let's consider any three numbers. For example, A, B, C. These three numbers belongs to natural numbers. I will write as A is related to B, and if it is ending with B, you should start with B. B is related to C. What is A is related to B? What is the condition? If A comma B, this is nothing but A is related to B. Okay, just remember. A is a factor of B. This is meaning what? What is A is related to B? Nothing but A is a factor of B, and this is nothing but B is a factor of C. Okay, if I will express this as B is equal to A times of into K1. K1 belongs to any natural number, and I will write this as C is equal to B into some K2. Can I write like this? K1, K2, the both are belongs to natural. The both are any natural number. What I will do here, I will take this as equation. I will take this as equation number 2. Okay. Substitute 1 in 2. I will substitute 1 in 2. Okay. What happens if I will substitute 1 in 2? I will get C is equal to in place of B, I am replacing this A into K1 into there is a K2 again. If simplify, implies C is equal to A into K1 K2. K1 K2 product of two natural numbers is again a natural number. We don't have any problem with this. If you want, you can write K1 K2 as some K. Okay, this belongs to natural number. C is equal to A into some K. Okay, what is the meaning that if you're writing C is equal to A into K, that is nothing but A is a factor of C. If A is a factor of C, that is nothing but A is related to C. Okay, that is nothing but what? A comma C belongs to relation. That is what we proved, right? Okay, if A is related to B, B is related to C, we have to show that A is related to C. Okay, this is our definition. This is our definition, right? A is related to B, A is related to B. Okay, B is related to C. We have to show that A is related to C finally. Okay, we got here finally. That implies that is nothing but relation R is transitive. Okay, like this, we should prove it is reflexive. Okay, it is symmetric transitive. Finally, therefore, we conclude that the relation R is reflexive, transitive, but not symmetric.